In this video, I'll show you how to solve a linear system with three unknowns using the transformation method. The question reads, solve the linear system below using matrices. Let's rewrite this system of linear equations with three unknowns as a matrix. And if we do that, we should end up with a matrix that's 3 by 4. So here we have a 3 by 4 matrix, 3 rows by 4 columns. And our goal is to convert this 3 by 3 matrix into its identity matrix, which looks like this. Here you have a 3 by 3 identity matrix, and to start, the first element that I'll be targeting is this 1. I want to make this 1 into a 0. Everything along this diagonal will become a 1, whereas everything else, this and this, will become zeros. At the end, when you have your identity matrix, these will serve as your solutions, your x, y, and z. To make this into a 0, I need to multiply row 3 by 2, then subtract row 3 from row 2. So let's document that. Row 3 times 2, row 3 minus row 2. Since only row 3 will be amended, rows 1 and 2 will remain unchanged. So let's rewrite those. Notice that row 1 and row 2 have stayed the same. Row 3 will become 0, negative 11, negative 8, and 6. Just to give you an example, if I multiply this by 2, and I take that product, 2, and subtract it from the element 2, I end up with 0. And you do the same thing with the other 3. My next target is this 2. I want to convert that 2 into a 0. And the way I do that is I'll multiply all of row 1 by 2, then subtract row 2 from row 1. So row 1 times 2, then I'll subtract row 2 from row 1. This tells me that only row 2 will be amended. Rows 1 and 3 will stay the same, so I'll rewrite them. Now let's do this together. If I multiply the elements in row 1 by 2, let's take for example 1. 1 times 2 is 2. This 2 subtract that 2 gives me 0. Another one. 4 times 2 is 8. 5 minus 8 gives us negative 3. And you'll do the same thing for the other 2. That's what you should end up with. My next target is this 3. I want to make that 3 into a 0. And by the way, you can choose different targets. It really depends on what works for you. So in our case, if I want to get rid of this 3 and make it into a 0, I'll multiply all of row 1 by 2, all of row 2 by 3, and then add row 1 and row 2 together. Row 1 plus row 2. Only row 1 will change. Therefore, 2 and 3 will remain the same, so I'll rewrite them. Let's do the first two elements together. Row 1 multiplied by 2, that's a 2. 0 times 3 is 0. 2 plus 0 is 2. Next one. 4 times 2 is 8. Negative 3 times 3 is negative 9. 8 plus negative 9 is negative 1. And this should be a 0, and this should be an 8. Our next target is to make this negative 11 into a 0. And the way you can do that is multiply row 2 by negative 11, row 3 by 3, and then add row 3 with row 2. This will be the only row that changes. Let's rewrite row 1 and row 2 the way they were. Let's do the first two elements that will change. Row 2 times negative 11 is 0. That times 3 is also 0, so this will become 0. This times negative 11 is positive 33. This times 3 is negative 33. That gives us 0 when we add them up, and the rest will become negative 2 and negative 4. My next target is this number. And to make this negative 2 into a 0, I have to multiply all of row 2 by negative 1, and then add row 2 to row 3. So row 2 times negative 1 And row 2 plus row 3 should give us what we're looking for. These two will remain the way they are. This times negative 1 gives us 0, plus this is 0. This times negative 1 is positive 3, plus 0 is positive 3. That becomes a 0. 2 times negative 1 is negative 2, plus negative 4 gives us negative 6. Lastly, we want to get rid of this negative 1, and we can easily do that by multiplying row 1 by 3 and then adding row 1 plus row 2. If we do that, we should end up with 6, 0, 0, and 18. That's your first row. And your second and third row will remain the way they are. Just to make sure we understand, remember I multiplied 2 by 3. That gave me 6. 6 plus 0 is 6. Negative 1 times 3 is negative 3. Negative 3 plus 3 gives us 0. And similarly, 8 times 3 is 24, plus negative 6 is positive 18. We are practically done. All we have to do now is divide row 1 by 6, row 2 by 3, and row 3 by negative 2. If we do that successfully, this becomes a 1, so does this, and so does this. This becomes a 3, this becomes negative 2, and this becomes positive 2. This tells us that our x value, this one, is 3, our y value is negative 2, and our z is positive 2. 3, negative 2, and 2 is the point of intersection for the linear system shown here. Here's a look at the work we've just done.